Good afternoon, everyone. My name is Latha. I am from CSE department. Today I am going to discuss about searching algorithms. Searching. What is meant by searching? Searching means it is the process of finding for a particular element whether it is available in the given list or not. If it is available, in which position it is there. So that is going to be discussed. List means collection of elements which are stored in continuous memory locations. That is called list. See here, for example, here this is my list. So this is the list which contains a size of 5. The index position starts from 0. The size is 5 here. Okay, for example, here I have taken 5 elements. Those are 10, 20, 30, 40, 50, and those are going to be stored in sequential manner. Now suppose if you want to search for any element, suppose my search element is called key element. Key element is 30. Suppose I am going to search for this element, whether this element is there or not. If it is there, in which position it is there. So that is, the searching is going to be taken in two different methods. The first method is linear search. The second one is binary search. See, two types of techniques are there to search for element. Those are linear search and binary search. Is coming to the first one, that is linear search. So linear search means sequential, means one after another we are going to compare our key value with those elements, if it is equal or not. If it is equal, then the element is going to be found at that particular location. Otherwise the element is not going to be found. That is going to be printed on the monitor. So now, for example, here now linear search here. So linear search, so first we have to provide the formula to the compiler. Suppose this is my list or this is my array. The size is 6 here. Suppose if you take the key element is 50. So in order to find out for this particular element, here we are going to start this searching process from the beginning position. That is what is 0th position. Okay, 0th position, whatever element is there here, 10. So we are going to make comparison. That is what here. See here, that is, so this is the formula. If so, this is the formula. Based on this formula, the search element is going to be compared here. So if this is true, means if it is true, means it is going to be printed element is found. Element is found at a position. That position is what here, I. See here, if it is true, it is going to be written that particular position. So now we'll write down the program. So this is the program regarding linear search here. So see here, this is the declaration part. So this is the declaration part. In this declaration part here, I have taken 4 variables, one array. My array name is A. The size is 20 here, and N I found equal to 0. So first, enter size of array. So first, this statement is going to be printed on the monitor, the size of the array. So means you have to give the size here. Suppose if you give the size is N equal to 5, means it is asking enter array elements, means you need to enter 5 elements. By using these scanf, those 5 elements are going to be stored in array. Means here for loop is there, I equal to 0, I less than n. What is our n value here? 5. Means I equal to 0, 0 less than 5. Yes, it is true. Then scanf percentage ampersand a of 0. Means suppose here this is your array. This is my array. So this is my array. My array name is A here. I equal to 0, 0 less than 5. Yes, it is true. So first element. So suppose if you enter the first element 10, the 10 is going to be stored at A of 0. A of 0. Ampersand A of 0. The next after executing this scanf here, compiler go back to for loop here. I plus plus I value is going to be incremented by 1. Now I becomes 1 here. 1 less than 5. Yes, it is true. Next, whatever the element you are entering the second time, that element is going to be stored at ampersand A of 1. Ampersand A of 1. So that is what assume, that is 20. Next, after executing the scanf here, go back to for loop I plus plus. Now I value is 2 here, 2 less than 5. Yes, it is true. If it is true, third element, suppose if you are entering third element 30, that is going to be stored at ampersand a of 2. Next, go back to for loop I plus plus. Now I becomes 3, 3 less than 5. Yes, it is true. So the fourth element is going to be stored at ampersand a of 3. So fourth element is assumed 40, that is going to be placed at a of 3. And the next again I plus plus, here I becomes 4, 4 less than 5. Yes, it is true. So fifth element, suppose if you enter the fifth element is 50, that is going to be stored at ampersand a of 4. After that, again go back to for loop. How many times this is going to be repeated? Till this condition becomes false. In the for loop we have given the size is 5 here. Till the condition becomes false, it is going to be iterated. So after that again go back to for loop here. Now I becomes 5 here. 5 less than 5. Is it true? No, it is not true. Here it is false. So control comes out of the loop. Only how many elements it is going to be accepted? 5 elements are going to be accepted, and those are going to be stored in this array in sequential manner. So after that we are asking enter search element. Enter search element. For suppose your search element is, if you want to search 30, my search element is 30, assume. Now that is going to be stored in key variable. Next, so this is the actual logic of linear search here. So this is the logic of linear search. So here again we'll write for loop starts from 0 to n. What is n here? 5. Again 0 less than 5. Yes, the condition true here, equal to 0, 0 less than 5, condition true. Then enter inside the for body loop here. So here inside for loop, here if condition is there, a of I. What is I here? 0. Means a of 0. A of 0 double equal to key. What is key element here? 30. Is a of 0 equal to 30 here? What is a of 0 here? 10. Is 10 equal to 30? No, this is not true. Condition false. So again go back to for loop I plus plus. Now I becomes 1. Now I becomes, for I equal to 0, it is not true. Now it is 1. So that is what here? A of 1. What is a of 1 here? 20. Is 20 double equal to 30? Is it true? No, again it is false. Again go back to for loop here. I plus plus is going to be carried out. Next I value becomes 2. Now next I value becomes 2 here, that is a of 2. A of 2 equal to key. What is key element here? 30. So what is a of 2 from the given array? 30. Is 30 equal to 30? Yes. Yes, here condition becomes true. Why? Because 30 equal to 30. So then if it is true, whenever this if condition is true, then compiler comes inside the if condition. So whatever the statement we have written under this if condition, those are going to be executed here. So yes, here condition is true. Then printf is going to be printed here. Search element is found at %d position. What is that position here? In third position. So we are getting the output as search element is found at third position. I indicates what here? 3. In which iteration we got the element? Third iteration. So search element is found at third position. So like that it is going to be printed. After printing that statement, and the next line is found equal to 1. So found equal to 1 indicates here the initial value of found equal to 0. Found equal to 1 means the element is found. The search element is found. So after found equal to 1 is set, then we are going to execute this break statement. What is the use of break here? So break, it is used for break the execution of the program in the middle itself. Why? Because here this is the loop till, so see here 0 to 5. So this is the loop we have written. Initial value 0 to less than 0 less than 5 means how many times this loop is going to be iterated? Till the end of the list. But here at this particular iteration only we got our element. So no need to go further, no need to go further. To avoid that one, here we are using break. So what is the use of break here? Simply it is going to break the execution of the program in the middle itself. Why? Because here we got our element, so no need to perform, no need to continue the searching process. So to avoid that one, to break that one, we are using break here. So immediately this for loop is going to be terminated here. So after that, see here, so after that, here break is going to be executed. Yes, that's it. Suppose assume your search element is not found. In that case, suppose assume something. Suppose your key element is 35. Here you have given key element is 35. See here, from 0 to 5, a of 0, that is 10 not equal to 35. Next 20 not equal to 35. 30 not equal to 35. 40 not equal to 35. 50 not equal to 35. So in that case, here after this for loop becomes fails, then it comes out of this for loop. So after that it checks if found equal to 0. Yes, found equal to 0. Why? Because here we didn't get our element, so found equal to 0 only. In that case it is going to print not found. Okay, so this is what here linear search. Linear search means simply we are going to start our searching process from beginning of the list to the end of the list. So that's why it is called a linear search, and also we can call it as sequential search. The next, binary search. The next, binary search. So this is also one of the searching technique, but it takes less time comparing to linear search. See here, suppose this is my list here. Suppose this is my list here. So one prerequisite is there for binary search. The list should be sorted. The list should be sorted. Then only the list should be sorted. Then only we can apply this binary search on that given list. So this is one of the prerequisite. So suppose assume this is my list. It contains 10 elements, and the index positions are starts from 0 to n minus 1. So this is my list here. See, now I am going to perform this binary search operation on that list. So before that, here assume the starting index position. Assume I am taking this is as low. The last value is indicating as high. Okay, after getting low and high value, so I am going to find out, or I am going to calculate mid value. So for that mid, so this is the formula, that is low plus high by 2. So this is a formula to calculate mid element, that is low plus high by 2. See here, what is low here? What is low position? 0. What is high position? 9 by 2. So this is what 4.5, but we will take only integer position, that is 4. So assume this is our mid element. This is our mid element. Okay. So this is by low position is 0, high position is 9, and mid position is 4th position. So now here we have to consider 3 cases. 3 cases are there. 3 cases are there. The first case is suppose if our key element is equal to a of mid. Suppose our key element means search element is equal to a of mid. Then one case, suppose if our search element is less than a of mid. The third case is suppose search element is greater than a of mid. Okay, we have to consider these three cases. The first one is if your search element is equal to mid element. In that case, simply we are going to print out the search element is found at this particular mid position. Next, suppose your search element is less than a of mid. Your search element is less than a of mid. In that case, we are going to reset high value. We are going to reset high value, that is mid minus 1. Why? Because here your search element is less than mid element means what here? Compulsory it should be in left half. Okay, compulsory that element must be in this left half. So we are going to perform searching operation in this left half only. So in this left half we have low value, but we don't have any high value. So that's why we are resetting high value by using this formula, that is mid minus 1. So mid minus 1 means 4 minus 1, 3. So here it is our high value. Means we are going to perform searching operation in this left half only. Next, third case. Suppose if your search element is greater than mid value, in that case we are going to reset low value, that is low equal to mid plus 1. Means if your key value, suppose your search element is 40, 40 is greater than 25. So our search element must be in this right half. So we are going to search for that element in this right portion. In that right portion high is there, but we don't have any low. So we are going to reset low by using this formula, that is low equal to mid plus 1. So now the low value will be here. So like that we are going to perform search operation. So now we'll take one example. This will take one example here. So this is the program regarding binary search. See here, for example, my list is assume that is my array that contain 10 elements. So this is the low value, this is the high value, this is my mid value. Yes. So initially low equal to 0, high equal 10 minus 1, n means 10. 10 minus 1, that is 9, high is 9, low equal to 0. Is 0 less than or equal to 9? Yes, it is true. Now we'll calculate mid value, that is 0 plus 9 by 2, that is 4, 4.5, but we'll take 4. A of 4 equal to mid. Next, I equal to 0, I less than n. See, n equal to 10 here, 0 less than 10. Yes, it is true. So now we'll start searching process. Key element double equal to A of mid. So here I will take 3 cases. In the first case, my key element is 25. My key element is 25. See, key equal to A of mid. What is key value here? 25. What is mid value? A of mid 25. Is 25 double equal to 25? Yes, it is true. Then it is going to be printed element found at percentage position. What is that position here? In which position it is available? 4th position. So here we got the output as 4th position, it is there. So this is for first case. The second case, suppose your key element is 10. Second case, your key element is 10. Now we'll start from here. Low equal to 0, high equal to 9, 0 less than or equal to 9. Yes, it is true. Mid value, that is 0 plus 9 by 2, 4. Next, 0 less than 10. Yes, it is true. Now key element. What is key element here? 10. Is 10 double equal to 25? Is it true here? No, it is not true. If it is not true, it comes out of this if condition. It goes to this if here. If your key is less than A of mid, if your key is less than A of mid, what is our key here? 0. 0 less than 25. Is it true? Yes, it is true. Yes, it is true. If it is true, then we are going to reset. This statement is going to be executed. That is high equal to mid minus 1. See here, this is our mid value. Mid minus 1. Mid minus 1 means mid means 4. Mid minus 1 means here it is. So this is our high value. So means in this list we are going to perform searching operation. So this is our high value. This is our low value. Means in that left portion only we are going to perform searching operation. So after resetting high value, again go back to while loop here. Why? Because here till this condition becomes false, it is going to be iterated. So what is low value here? 0. What is high value here? Now what is high value here? 3. So high value is 3. 0 less than or equal to 3. Yes, it is true. Now mid value. It is going to be calculated mid value here. That is 0 plus 3 by 2. 0 plus 3 by 2 means 1.5. We'll take integer, that is 1. Next, key value. What is our key value here? 10. Is 10 double equal to A of mid? What is A of mid here? So this is our A of mid. So this is our A of mid. Mid equal to low plus high by 2, 1. So this is our A of mid. Is 10 double key equal to A of mid. Our key element is 10. Mid element is also 10. Is key equal to A of mid? Yes, it is true. Then element is found at percentage D position. What is that position here? In which position it is available? In first position it is available. So that is going to be printed on the monitor. For this case, in first position it is available. The next, in the suppose third case, if you take the key value as, if you take the key value as 40. As now we'll start the process from here. Low equal to 0, high equal to 10 minus 1, 9. As now we'll calculate the mid value, that is 0 plus 9 by 2, 4. That is A of 4. A of 4 is our mid element. What is our key element here? Our key element is 40. Is 40 double equal to 25? No, it is not true. So it goes to this if is 40 less than 25. It is also false. Again go to else if is 40 greater than 25. Yes, it is true. Here it is true. So this statement is going to be executed here. Low equal to mid plus 1 means here we are going to search in this right portion. We are going to search in this right portion. So in this right portion we are having high value, but we don't have any low value. That low value is going to be reset by using this formula, that is mid plus 1. What is mid here? 4. So 4 plus 1 means 5. So this is our low value. So now in this right half we are going to perform searching operation. Again go back to while loop, 0 less than or equal to. So now what is our low value here? 5. 5 less than or equal to 9. Yes, it is true. As now key double equal to a of mid. What is our key value here? 40. What is our mid value here? 0 plus what is low value here? 5. What is high value? 0. 5 plus 9 by 2, that is 14 by 2, that is 7. So this 7 is our mid value. 7 is our mid value. As now key element is what here? 40. Is 40 double equal to 40? Yes, it is true. So now it is going to be printed. Element is found at which position? 7th position. So element is found at 7th position. So like that the binary search is going to be performed. Still now we have discussed about searching process, and types of searching is linear search and binary search. So coming to the linear search, so it is going to be performed in sequential order. The next one is binary search here. So in binary search we are dealing with the low value, high value. By taking low and high value we are going to calculate mid value. So based on that we are going to decide the search element whether it is in right portion or in left portion, or it is at mid position. So this is the program regarding binary search. In the next session we'll continue this one. Thank you.